This is section 1.2, and we're looking at levels of measurement. So, the way a set of data is measured is called its level of measurement. And this level can help us determine what statistical operations can or cannot be used. All right, so we have four main levels of measurement listed here, and they go from lowest to highest. So nominal is the lowest level of measurement. We might say it's the least refined or least specific. Then to the highest level here is ratio level. That would be the most precise, most specific, most characteristics that we can have. So, in order from lowest to highest, these are the nominal level, ordinal, interval, and ratio level. If you need a little, I guess it's a memory device, but you can remember these with the word noir, like film noir, from lowest to highest. Okay, now let's get into the different types, beginning with nominal. Now, this level of measurement, the data here is qualitative, so sorted by categories based on some attributes. And a key characteristic of this data is that there is no specific order for the categories, no inherent ordering that most people would understand. So, for an example of this, we could do something like different brands of cars. So the data points would be different brands like Toyota, Honda, Jeep, etc. And there is no strict order for how those have to fall into line. It's not like Toyota is number one and then always Honda is number two and Jeep is number three. No, there's not a set order. You could list those names in any order and still have a meaningful result. Okay, so that is in contrast to the next level of measurement, the ordinal level, which is still qualitative data, but this has categories that can be ordered. They do have some inherent ordering to them. So can be ordered. Okay, so it's like we're gaining this new characteristic at this level of measurement. We still have qualitative data like the nominal level, but we have gained the ability to order the categories at the ordinal level. Ordinal, order, memory device. So for an example here, a classic one at the ordinal level is satisfaction surveys. So survey answers of things like bad, in the middle, okay, and then good. Okay. So those are still qualitative data points, but they do have an order to them. You could order them from worst to best, so going from bad to good in order, or you could go from best to worst, starting with good and then go in order down to bad, and okay is just in the middle. So that would be an ordinal level of measurement. Next, we have the interval level, and here we are now working with quantitative data. Okay, and quantitative data inherits this idea of ordering because once we switch to quantitative, those are numbers, and numbers can be put in order, we've known that since like kindergarten, right? So quantitative data with order. And here we can measure differences between data points. Okay, so differences between data points would be subtracting one data value from another. We're looking at the intervals between those data points. Okay, so let's say we were looking at temperature, and if today it is 92 degrees Fahrenheit and yesterday it was 87, um, those are in order. I mean, one's higher, one's lower, and we can measure the difference between those. That is a 5-degree difference, and that's a meaningful difference there, right? Like we can tell, okay, how much warmer is it today than yesterday? 5 degrees. Okay. Now, another characteristic on this interval level, which we'll talk more about in just a second, is that there's no true zero measurements. So going back to the idea of temperature, the Fahrenheit scale, I mean, it does have 0 degrees, but that isn't necessarily truly meaningful. Um, Again, we'll talk about this a little more in just a bit. But on the scale of Fahrenheit, I mean, freezing is 32 degrees, boiling is 212. So there's not really like a 0 point necessarily that everyone can agree upon. All right. So that could be one example. Another really good one to think about here is different dates, years. So like 2021, 1960, 200 BCE, all right, etc. These have an order. We can see which dates are older and which dates are more current. We can measure differences, like the difference between 2021 and 1960 is 61 years. But there's, again, not a true zero to this system. We do have BCE and AD, or BC and AD, however you reference it. But we can go as far as we want really in either direction. So there is a zero, but then it doesn't stop on one side or the other. We can go back into BCE as long as we want. We can go into AD as long as we want, or CE. Okay, there's the two systems there. But there's not like a firm stopping point for the scale. Okay. So that one is kind of a complex level there. We'll look at some examples in a bit. So that's interval. And then ratio level is quantitative data. Again. All right. It has order to it. So you're noticing we inherit that order. All right. And we also inherit the ability to measure differences. So it has order, it has differences. And then here we also get a true zero. All right. So an example here might be something like, to use a previous example, the weight of kittens. Okay, so it's quantitative. There is an order. to the values. The differences make sense. We can see, if you've got a kitten who's 1.6 pounds and a kitten who's 1.3 pounds, the difference between those is 0.3 pounds, and that is meaningful. And there's also a firm stop, a true zero. Weight only goes down to zero. We don't have negative numbers for weight. You can't go forever in both directions. Now, I would hope that, we never have a kitten who's exactly 0 pounds, because that kitten would not exist. It's not particularly realistic for this example, but to the scale of weight, there is a true zero. All right. There is a firm, hey, you have to stop here to that system. Now, the other thing here to kind of help with remembering this is the ratio level is that ratios, which are phrases like twice something, like twice as big or twice as tall, twice as many, or half as big, half as tall, half as many, things like that. Those make sense. All right. So like with the weight of kittens, if you had a kitten who's 0.8 pounds and a kitten who's 1.6 pounds, you could say, oh yes, that second kitten is twice as big as the first. He weighs twice as much. With things like years, we can't necessarily say that. So like if you're looking at 200 BCE, can you say that is twice as much as 100 BCE? Twice as old, but as compared to what? As compared to year zero or as compared to the year 2021? The ratios don't work out at the interval level. They only work at the ratio level. So you can kind of see that this matches up here. Different data levels of measurement get different characteristics, and they kind of waterfall here. So ratio level, let's see, how do we want to waterfall this? Nominal has order, and then we flow down and we get the ordinal level. Oops. Nominal has no order. We just get qualitative data. Okay, names, basically. Nom, name. So we get names, categories, no order. Ordinal, we acquire order. And then we can flow down to interval, in which we have order, but we acquire the ability to look at intervals, okay, with meaningful results. And then you keep all of those things and flow down to the ratio level, where ratios make sense and we get a true zero. So each time you get a new level here, you inherit the characteristics of the previous level. All right. Another thing to notice with these is that the first two levels are categorical variables, okay, with that qualitative data. And then the second two levels here would be numerical variables. They have quantitative data. So some data sets can be a little tricky in this regard, but that is a good thing to keep in mind. All right. So in the next video, we're going to do an example determining measurement level for different data sets.